Question 5, we have our slope. So let's draw our little slope here, and our slope is 40 degrees. So we'll put 40 degrees onto our slope there. And we have our block here of 20 kilograms. As I put my 20 on here, and I put my 40 degrees in there, I'm just going to split this straight away into 20 cos 40 and 20 sine 40. It's also going to be a normal reaction to it there, and it's being pulled up the slope, so we've got some force pulling it up the slope there. There must be some friction pulling it back as well, because we've got to try and find out what we've been told what the coefficient of friction is. So there's my force diagram, and we'll start by looking at the forces perpendicular to the slope. That's just R minus the 20 cos 40, and that equals 0. And so R equals 20 cos 40, and 20 cos 40 is 150.145, or 150 newtons, that we've got there. Find the tension in the rope. So the tension in the rope now then, so we're looking to go in this direction. The force pulling it up is P. We've also got pulling it down the slope is 20 sine 40. And we've also got the friction here, and of course the friction is going to be equal to mu times R. The mu we were told was 0.2, so 0.2 times by 150 is 30. So there's the force there. And does this move? Okay, I've just been looking for the acceleration here. So it's paused at a constant speed. So if it's constant speed, its acceleration is 0. So the force is actually 0 here. So P is equal to 30, add 20 sine 40, and tapping that in gives 156.015. So yeah, 156 newtons is the force there. The tension in the rope is now increased, so the block accelerates up the slope at 1.8 meters per second. So let's just go back to that previous line there, and here was the resultant force, and this is now equal to the mass times the acceleration. So this is now equal to 20 times by an acceleration of 1.8. And so now the propelling force is increased into 20 times 1.8 plus 30 plus the 20 sine 40, and that works out to be 192 newtons. State 2 modelling assumptions that we've made. So usual modelling assumptions is that we've modelled the block as a particle, and we've modelled the rope here. The string is light, so inextensible string, no mass, and I suppose we could even add that there's no air resistance as well. We're only talking about the friction between the block and the plane, so maybe no resistance as well, no air resistance as well.